the category two. So some of the larger vision projects that Frank laid out in this was our goals. You saw we have, I think, nearly 400 sites, but there are nearly 3,900 accredited institutions that we feel are potential members of the National Research or users of the National Research Platform. So this is how far we want to be able to scale. The vision is connecting every community college, every minority serving institution, every college, every university, including all urban, rural, and tribal institutions. And then engage, empower every student and researcher. So the connectivity and the community and the combination is what creates the National Research Platform. So the goal is to create cyber infrastructure that is manageable, that we can then deploy on top of open science, open data, open source, open infrastructure, open compute, open storage, openness for an open society. So the Open Programmable Infrastructure Project seems to fit right into our very open plan. One of the most important features of this community with a shared vision is it allows this central hub to be the attachment point for many projects. So funded projects, anything coming out of NSF through the CC Star campus cyber infrastructure awards, they now require at least 20% of that be committed to a national shared platform. And so the Open Science Grid and the National Research Platform are a natural target for these externally funded projects to build on top of. This is
John,
what,
let me just stop you for a second. We have
sure.
12 minutes. I would highly recommend that we dive into what your request is from OPI, where you would like us to work with you.
Oh yeah, sure. I will blow through these pretty quickly, but those were at the end of my slide deck. How many minutes do we have left?
12 minutes.
Okay, I will move faster. So this is the National Research Platform. This is the 3 major data centers that were funded to put up lots of A100s at the Lincoln, Nebraska and MGHPCC sites, and then 64, A10s at those sites and A100s at the UCSD. And then we also have 32 U55C SmartNICs running ESNet SmartNIC framework. This shows the deployment of the storage and compute nodes. It shows you where all these sites are located. You notice we have quite a bit of coverage in the central states. The Great Plains Network is one of our premier members, as is NicerNet, which serves as quite a bit of the New York, East Coast, and international. I'll just go through the bring your own resources we've shown. This is a big thing. We're trying to combine CS and R&D and domain R&D onto the same platform. And so we have production and testbed in the same cyber infrastructure. This is just pointing out that the new architectures are what will be driving new research. And so things like DPUs and accelerators and FPGAs and quantum computing, these are all the things that we are focusing towards. Classroom innovation. These are kind of see who's using what in our cluster. Here's the layer 2 network automation stuff that I was talking about. This shows you the footprint and interconnection of our sites, and you see NRP. You can see anytime there's an NRP block, we have facilities at these sites. These are the backbone links that we use: Fabric, ESNet, Internet 2, and then the local scenic PacWave research. Here's the Bluefield deployment that we currently have. And this is, again, on the backbone sites in scenic. We have 7 sites, one in Guam, 4 in the Pacific Wave backbone, including SDSC, 1 in Chicago, and 1 at NicerNet. These green blocks are where these are deployed. This is the SC24 research experiments that are happening in Atlanta this fall. And so you can see we're deployed on the backbone at all these points for wide area experiments using the Bluefield systems. I'll just go through these. This is the use case that we're one of the use cases we're trying to solve for the scenic specific systems. Typically, our ESNet sense orchestrators talk to the primary DMZ switch routers, or even like UCSD and Caltech, deeper into the switch fabric. And a lot of campuses that are coming on don't have this level of infrastructure. They can get 2 circuits from Scenic. One is their high performance research network, and the other is their DC, which carries internet routes. But if you're not allowed to control this campus border router, you have to drop that networking layer 2 provisioning control off to the Bluefield 2, so you can then provision at a host level to a 400 gig connected system the layer 2 paths to communicate across those wide area networks to the other research sites. This is a second use case. This is NicerNet, where we have 3 networks we have to talk to. And so we have a 10 gig NIC in the same machine as the Bluefield that gives us the internet route. The Bluefield is going to be doing the BGP peering between the content delivery network that has all this NVMe storage that we want to connect to this device, and then the RNE network that does the wide area network connectivity. What we're interested in from NRP collaborations from the Open Programmable Infrastructure Project, one of the most enticing systems that you are developing is this secure zero-touch provisioning. As I said, we do IPMI and up management of systems, and it's all done by hand through logging in through jump hosts or VPNs, getting onto the BMC and loading OS remote, and just the automation capabilities that we see possible through secure zero-touch provisioning. That's a huge time savings for our team. We have 3 full-time employees doing cluster maintenance, and they're distributed across the MGHPCC, UNL, and SDSC sites. Other things I talked about, the host-based networking. We need to figure out how to use host-based networking in DPUs and out of DPUs in IPUs. We also need to figure out how to use both DPUs and IPUs for SBDK. One very important thing in our community is P4, and I'm still struggling to figure out what NVIDIA is doing with P4. They're pointing us towards Dokaflow, which is good, but it's not the P4 we're looking for. It'll cause us to do a lot of writing, and so we have to figure out how to use Dokaflow in our P4 environment. The other thing that we're very interested in is converting the Docker Compose to Helm charts for the POC lab. And that will just help me stand up our Bluefield test bed as a POC for our community. And I also, we're very interested in the DPU operators we've been hearing about from NVIDIA and from Red Hat for the provisioning and control of the devices.
So John, if you can go back, please.
Sure.
If you had to put these in priority, is this the right order? Meaning, do we start with zero touch provisioning and then move down?
Both of these simultaneously. I want to get a handle on BGP peering and HBN, and I want to start learning how to deploy a secure zero touch provision.
Okay, got it. Thank you. Please move ahead.
Now, this will help a lot of people technically in the community. The first one will help us physically managing our systems. That will give our admins more time to help users instead of managing firmware upgrades and playing whack-a-mole. Because that's very intense doing that remotely by hand.
Got it. Okay,
Anyhow,
so
these are the devices that we're interested in, the Bluefields, the IPU from Intel, and then the FPGA, Agilex F series IPU. Those three devices are the first focus, but we're also interested in the Marvell and the Pensando and the other devices. That's basically the end of my slides.
That's brilliant. So a few notes. As you know, we have partners in this program that are very good at P4. I mean, NVIDIA looks at P4 as something that I need to translate with Dokaflow, but I think the Intel IPU can do it natively, and so can the FPGA. So you do have other partners here that do very well with P4.
Yeah.
Of course, our goal is to have you benefit from everybody, but I think that if it's causing you heartburn on the Dokaflow, which again, I think it shouldn't, but if it does, then there are other options.
Well,
and I think
it was more of the marketing materials. Say you guys have P4.
Yeah, we need to do a deep dive on that. But again, you have other great options here in the group. Intel and Marvell support P4.
Yes.
As you said it yourself, both in their FPGAs and in their IPUs. So you've got these options.
The other thing I would love to see is all the work we've been doing with the U55C and the U280s using the ESNet SmartNIC. Well, they've kind of heard us talking about the gRPC services that everybody's standing up to manage these things. And it looks like they're going to put a gRPC service in the ESNet SmartNIC.
I see.
So this adds another layer of Xilinx AMD-based FPGAs being added to this stack of IPU, DPU, FPGA SmartNIC.
That's interesting.
I saw somebody that did a Rocky implementation in FPGA.
Yeah, I saw some of those too, but I think that Pensando is not as active on the FPGA side. We might want to nudge them and see if they're willing to work with us. But I do know that there are other partners that are using these type of FPGA, so we might leverage other partners here.
Great. Yeah, so we also have at UCSD a group that does FPGA middleware. It's called Corundum, and it's I don't know exactly what it does, but allows you to write code that will run on either Xilinx or Intel.
Very cool. Yeah, you told me about that. Very, very cool. And I think that's something that the industry has been missing for quite a bit of time. I'm not sure if OPI is the right vehicle for that, but
no, it's different, but it could be another project that we could get interested in conforming with the OPI.
Yeah, that's right. That's right. Okay, so we are out of time, but let me stop the recording.